So we're still looking at completing the square today, but yesterday I kept you in this little nice, neat, happy world where everything worked out to be an integer answer. Right? Yes, we sort of looked at these unique situations where we had to follow a decimal through, but we were still nice and neat in the end, and everything worked out to be an integer. The reality is that that's not always the case. Okay, realistically, there are times that we will not get an integer answer. Okay, and even more realistically, we won't get a rational answer. So what's a rational number?
The one that can turn into a fraction.
Excuse me?
There it is.
Thank you.
A number that doesn't repeat.
No, it can repeat. It can. A rational number is anything that can be written as a fraction or a decimal. Okay, so repeating decimals can be written as a fraction. Okay, irrational numbers are the other half of that, and those are numbers that can't be turned into a fraction, which means they're decimals that go on for forever and never repeat. They're non-terminating, non-repeating decimals, right? Pi and our weird square roots. So square roots make up a large percent of our irrational numbers. Okay, so today when we're looking at completing the square, we're not going to get to the spot where we have this nice, neat, perfect square that we can just type into our calculator and get a number out of. Instead, we're going to get something weird. So for example, let's say we have x squared plus, here's the geese, 8x equals 1. Is this in the correct form for completing the square?
Yes.
Yes. So we're going to start this with all the same steps that we looked at yesterday. So step 1, find b. What is b? 8. We are going to then take half of that, which is 4. We are then going to square 4, which is 16. What are we going to do with that 16? We are going to add it to each side. So we're going to add a 16 on the right. We're going to add a 16 on the left, right? Because whatever we do to one side of an equation, we have to do to the other. How do we know that this is an equation?
It says equal.
It has an equal sign. How do we know that we can use the word solve?
That's an equal sign.
Because it's an equation to start with, right? We solve equations. We simplify expressions. Okay, so on the right-hand side, what is 1 plus 16? 17. Don't. Okay, on the left-hand side, we're going to factor, and we know that it always factors into the middle number from our list. So I've noticed some of you are writing like 8, 4, 16. That's fine too. Right? There's nothing that says you have to write it in that horizontal fashion with the arrows or anything. Okay, that's just sort of what I do mentally to keep track. Okay, so we'll get an 8 or an x plus 4 squared. Okay, so now when we get to this step, you should be going, ooh, that doesn't look like what I saw yesterday. Because we now know that we want to get rid of the exponent of 2. And to get rid of that exponent of 2, we are going to square root each side, which is no problem on the left because x plus 4 squared square rooted is just x plus 4, and then I start to hear the calculators clicking. But if you put the square root of 17 into your calculator, what are you going to get?
4.123.
An irrational number. A decimal that goes on for forever. Which means the only way that you can write it down is to approximate. How does Mrs. McKinney feel about approximating?
No.
Nope. Nope, right? We don't want to approximate. So maybe we need a t-shirt that just deals something with not approximating. I don't know what that would be. Okay, so we do not want to approximate this. So do not put this in your calculator and round it. Okay, we are not dealing with the situation that we are ready for an exact answer. We don't know what else could be done with this. We do not want to round, which means the square root of 17 is just plus or minus the square root of 17. I can't do anything with that.
We still have to subtract 4 from both sides.
We do still have to solve though. So to solve this, how would we undo adding 4?
Subtract.
We would subtract 4. Okay, so remember when we were talking about radicals and we talked about how to add and subtract them? And I said, okay, it's going to be really important that we understand the basics of adding and subtracting. Most importantly, so that we know when we can't add them. What's our rule for adding and subtracting radicals? What has to happen? Can I add 3 square root 2 plus 7 square root 2?
Yeah.
Yes, what does that turn into? 10 square root 2, right? I can add them because they have a matching label.
But you can't add the 4.
Can I add the square root of 17 minus 4?
No.
No, because they do not have matching labels. The 4 doesn't have a label at all with it. So this just becomes x equals plus or minus the square root of 17 minus 4. It is a bizarre answer. How many answers is that? 2. Right? One answer is positive square root 17 minus 4. And one answer is negative square root 17 minus 4. Now, some things you have to be very careful of. Make sure that when you are writing down your final answer, you don't get square root happy. Okay, I have a lot of students who just love that square root symbol too much, and they'll say this. Awesome. Okay, they'll put down plus or minus the square root of 17. Even sort of like that. Is that correct? No, because the only thing that is inside the square root is the 17. Don't get anything extra underneath there. Okay? So as weird as this is our answer. And my student's like, oh, that's even easier than what we did yesterday. It sure is. Unless, I know, you all knew that was coming, right? How about we have y squared plus 20y plus 12 equals 0.
Subtract 12.
Is this in the correct form to complete the square?
No.
No. What do we need to do first?
Subtract 12.
Subtract the 12. Okay, so now we're in the correct form.
22.
What does b equal?
20.
Okay, so what's half of 20? 10. What is 10 squared? 100. What are we going to do with that 100? Add it to each side. We did great with the negative yesterday. I was really happy about that. So negative 12 plus 100 gives us what?
Negative 112. Or
88.
wait, no, yeah.
Our middle number there is 10.
Square root.
Okay, so we'll square root each side. 88 is not a perfect square, right? You can tell that 88 is not a perfect square because if you put it into your calculator, you get the big long decimal that doesn't end. Okay, so we'll have plus or minus the square root of 88.
Subtract 2.
Then we will subtract the 10.
Y equals square root.
My students are like, but Mrs. McKinney, that is what we just did. But that is not the answer. Why not? Up. Say it again, Eric.
Can we prime factor?
Shouldn't we prime factor and simplify 88?
Yeah.
Because we know how to deal with square roots, and just like we would never write a fraction as 4/8, we should never leave a square root not simplified. So we need to prime factor and simplify 88. So what does 88 split into?
Or 11 and 8.
Okay. 2 and 4.
2.
2 and 2. So let's see. 2, 2, 2, 11. So we have a pair of 2's. So y equals plus or minus 2 square root 22
Yeah.
minus 10. That's what we have to have as our answer.
Wait, so what's our,
So as soon as we open the door for having irrational answers or having answers with square roots in it, we're back to that position that we need to make sure all of our square roots are simplified. Right, I know it's annoying. But there's also a good piece, because if they're like this, and it's already simplified, there's less work. Or even better yet, oh, sorry, any more writing? What happens if it's this? Is this in the correct form?
No.
Nope.
Subtract 22.
I mean, hopefully at this point we're like, okay, yeah, I know the steps for completing the square. So what does b equal?
4.
4, half of it,
2.
squared.
4.
So I'm gonna add that 4 to each side.
Square root.
Then I'm gonna square root. What is the square root of negative 18?
No. We're gonna get NRS.
NRS. Can we go any further? As soon as we see a negative underneath the square root, step 1, step 500. We stop everything that we are doing and we put